Example number 1 asks us to decide where a function is continuous given a graph of the function. So there's 4 different graphs there. I'm going to go ahead and draw those out for you. Okay. My graphs are clearly not going to be as good as the ones in the book, but it'll get the general idea across. So the first graph looks something like this. It's got a graph that comes across like this. Okay, where the top ends are open, the bottom ends are closed, and these occur at integer values. So 2 would be another one that would come in here just like this. So if we want to know where it's continuous, well, a function is continuous anywhere where the limit coming from the left is the same as the limit coming from the right, which is the value of the function. So here, like let's take this point right here. Well, this is continuous from the right because as I come in from the right side, the height value of the function is the same as the limit value. However, from the left side, it's not. So there's a point of discontinuity. So this function is continuous. If you look at it, it's continuous except for at the integer values. So we would just write down that it's continuous everywhere except for at these integer values. Okay. Now the next one, the next graph looks something like this. It kind of goes, it's a little squiggly until we get to -1, then it's filled in, and then it's open again, like this, and then it does some more things. It squiggles down like this, and then it comes back up like that, and then of course it jumps back up here, and then it continues on its merry way that way. Now this function is discontinuous on these two x values, so right here it's not continuous, and right here at 1 it's not continuous. Now the next function looks something like this. I'm going to do it in a different color here. Okay, close enough. Now this function's continuous everywhere. Now it's not differentiable at these x values where we have these peaks, but it is continuous. Okay, because the limit from the left is the same as the limit from the right, which is the same as the function value at that point. And the last one looks like this. Okay, and this is continuous everywhere except right here at this x value. And that's because although the limit from the left is the same as the limit from the right, it is not equal to f at that x value.